we teach. In the previous class, we have seen how to find out eigenvectors. Now we will see the properties of eigenvalues. Suppose A is a square matrix and transpose of A is A transpose, will have same eigenvalues. That means A comma A transpose will have same values, eigenvalues. The eigenvalues of an triangular matrix are diagonal matrix. What is meant by triangular matrix? That means suppose A, B, C, D, E, F. This is a matrix. Here the number of zeros, the zeros are in the form of a triangle. This is called as lower triangular, or otherwise if the number of if the zeros are in the form of this, some G, 0, here also 0, here also 0, some G dash, some G double dash. Suppose if a matrix is A, B, C, D, 0, 0, 0, 0, 0. Or again we can take here also 0 and here some E. Here now here it is in the form of a triangle. You can write here also 0. So this is of the form of a triangle. So this is also called as a triangular matrix. So for triangular matrix, the eigenvalues will be diagonal matrix. Here this is larger triangle. If we consider only 0, 0, 0, here some C, F, H, A, B and A dash. This is another triangular matrix. Here the diagonal elements are not equal to 0. So this is these will be our eigenvalues. This is the triangle which is in the upside and here the triangle shape is in the downside. So eigenvalues of a triangular matrix are its diagonal elements. The eigenvalues of a diagonal matrix are diagonal elements. What is a diagonal matrix? Only the diagonal elements will be present and all other values will be equals to 0. So this is a diagonal and the eigenvalues will be only A, B, C in that matrix. The eigenvalues of an idempotent matrix are either 0 or unity. What is idempotent matrix? When A square is equals to A, then we can say that is an idempotent matrix. The sum of eigenvalues of a matrix is sum of its diagonal elements. That means when we add the eigenvalues, if suppose if a matrix have two eigenvalues and when we add them, what will be equals to sum of diagonal elements? That is sum of A plus D. This is the diagonal matrix and this is the diagonal elements A and D. So it will be equals to A plus D. Lambda 1 plus lambda 2 equals to A plus D. The product of eigenvalues of a matrix is its determinant of the matrix. If lambda 1 into lambda 2 is equals to determinant of that matrix, that is if we take as matrix here, it will be det A. If lambda is an eigenvalue of A, then for A inverse we will have 1 by lambda is the eigenvalue. If lambda 1, lambda 2 and lambda and so on up to lambda n are eigenvalues of a matrix, then A power m has eigenvalues of lambda 1 power m, lambda 2 power m and so on up to lambda n power n. Suppose A has eigenvalues of 1, 5, 9. Then if you want to find out for A power 3, then the eigenvalues will be 1 power cube, 2, 5 cube and cube. If lambda is an eigenvalue of non-singular matrix of A, then det A by A is an eigenvalue of det adjoint A. Okay. If lambda is an eigenvalue of orthogonal matrix, then 1 by lambda will be its eigenvalue. That is 1 by lambda will be eigenvalue of orthogonal matrix. Now let us see some questions here. If A is equals to 1, 0, minus 1, 0, 2, 3, 0, 0, 4, then what are the eigenvalues of A inverse? We have seen no, if for eigenvalues of A is lambda, for A inverse it will be 1 by lambda. So simply reverse this eigenvalues given, that is 1 by 1, 1 by 2, 1 by 4. Next, eigenvalues of A are 1, minus 1 and 2. What will be the eigenvalues of det A? Simply find out what will be eigenvalues of adjoint A. Simply find out det A value and we will get det A by lambda is the eigenvalue of adjoint A. That means det A means product of eigenvalues. So what are the eigenvalues? 1. So 1 into minus 1 into 2. We will get minus 2. This is det A. Now det A by lambda 1. That means minus 2 by 1 is first eigenvalue. Minus 2 by minus 1 will be second eigenvalue. Minus 2 by 2 will be our third eigenvalue. So the eigenvalues are minus 2, 2 and 1. Now if a matrix A is given, then find out the eigenvalues of 8a cube plus 5a square minus 6a plus 2y. That means if we done this whole equation, if we solve this whole equation, what will be the eigenvalue of that equation? They gave just simply matrix A. So how to find out? First, see here we have a cube, a square, a. Okay. Now first, what are the eigenvalues of a? Here they gave in the question is 1, 3, 2. Here eigenvalues is 1, 3, minus 2. Now for a cube means what did I say? The eigenvalues will be cubed. That is lambda cube. That is equals to 1 cube, 3 cube, minus 2 whole cube. That means minus 8. 3 cube means 27. 1 cube means 1. And for a square, 1 square 1, 3 square 9 and minus 2 whole square it will become 4. For a already they given, so we are taking. For I means 1 0 0 0 1 0 0 0 1. Those will be only the diagonal elements, that is 1 comma 1 comma 1. So eigenvalue of 1 means, now product this is 3 here. So 3 into 1, no, the eigenvalue. So in place of a cube substitute 1 plus 5 into, in place of a square substitute 1 and in place of a substitute here 1 and my 2 into again for I substitute the 1 value. So we will get answer as 4. For 3 means take this column here. For 3 means for a cube what we got here 27. So 3 into 27 plus 5 into a square, that means 5 into 9 minus 6 into a. 6a value is 3. So plus 2 into 1, that is equals to 110. Next for minus 2 means take the last column here. Okay, for minus 2 what we will get 3 into a cube value is minus 8 plus 5 into a square value is 4. So 5 into 4 minus 6 into a value is again minus 2 plus 2 into y. I value is 1, that is equals to minus 24 plus 20 minus 6 into minus 2 plus 12 plus 2. We will get as 10. Okay. So these are the eigenvalues corresponding to the given eigenvalues. Now let us see another problem. Find sum and product of eigenvalues. Given A matrix is this. What is the sum of eigenvalues? Simply add the diagonal elements. That is 2 plus 1 plus 2. That is equals to 5. Product of eigenvalue means depth of that given matrix. What is the determinant of this matrix? 2 into 1 into 2. That is 2 minus 1 into 0 is 0 minus 3 into 2 into minus 2 minus 4 minus 1 into 1 minus 1 plus of minus 2. So we will write directly as minus 2. Minus 2 into 0 is 0 minus of 1 into 1. So minus 1. So what we will get 4 minus 3 into minus first we will solve in the brackets. Minus 4 minus 1 means minus 5. So minus 3 into minus 5 means plus 15. Minus 2 into minus 1 means plus 2. The answer is equals to 21. Simple. The sum and product means here sum is 5 and product is 21.